This is the introduction to the Level 1 project video series. What is a Level 1 project? The Rocket Fizix Level 1 project is not the same as a Level 1 rocket kit. Most kit manufacturers use a level system to rate the complexity of their rockets. They define a Level 1 kit as a rocket that is easy to construct and fly. That level rating is based only on how challenging it is to build a rocket that someone else has already designed for you. Rocket Fizix isn't interested in how challenging a rocket is to build. We're more interested in how challenging it is to design. Rocket Fizix levels are based on design complexity, not just construction and flying complexity. Rocket Fizix defines a Level 1 project as a rocket that is limited to an A power level engine, is built from traditional balsa wood and paper components, and uses a simple streamer or plastic parachute recovery system. Even if you have built some rocket kits, you are not prepared to design a rocket from scratch without first learning some basic design techniques and learning how to use the tools of the trade. Don't underestimate just how much work and skill is required to produce the original rocket design. When you buy a kit, you are paying someone else to do all that design work for you. If you want to be creative and build original designs, you will first have to learn quite a few design skills. You will build and fly the rocket you design in this project, but the focus is really on learning the design process. It will be tempting to just copy the examples and shortcut the design process so you can get around to building and flying it. But if you do that, you're going to be cheating yourself. You just won't learn what you need to design higher level projects. Try to focus on learning the design process and pay attention to the details. Who is this project for? The Level 1 project is intended for those who have little or no experience designing model rockets. Remember, experience building kits is not the same as experience designing from scratch. Everyone who wants to do higher level design projects needs to do this project first. This project is for people who want to learn to design their own original rockets based on performance requirements. If you are only interested in building rockets, you should probably just go ahead and buy a kit. Designing from scratch is challenging and rewarding, but it's also a lot more work than you probably realize. Don't let that stop you. If you focus on learning the details of the design process, you will get a lot more out of rocketry than you ever would if you only ever built kits. Before starting this project, you do need to watch the Rocketry Basics video series so you will be familiar with basic rocket terminology and concepts. What will you learn about during this project? Understanding design requirements. Until you understand how to read and interpret design requirements, you won't be able to design a rocket because you won't know what you're designing. Laying out an airframe. This is how you establish the basic structure of your design. Without a layout, you won't even know what parts you need so much as how much to put them together. You'll learn to select parts and create a parts list. The parts list is the foundation of your design. If you don't know how to select parts, and if you don't make a disciplined parts list, you're going to waste a lot of time going in circles. You're not going to be able to complete the design, and you certainly won't be able to build it because you won't know what to build it from. Most new designers do not put nearly enough effort into their parts list. You should make your parts list a very high priority while working on this project. It will make the difference between success and failure in this project and in all your future projects. We'll learn to enter your design into a CAD/simulation program. There are several very good CAD simulation programs that are designed specifically for model rockets. You will use them to generate an assembly drawing which defines how your rocket is put together, and you will use them to simulate your rocket's performance. In later projects, you will learn how to use simulation data to improve your design to further enhance performance. We will learn how to plan the production of your design. When you buy a kit, it comes with assembly instructions. The designer has already worked out all the details of how to build the rocket, so all you have to do is follow the instructions. Since you will be the designer of your own rocket, you will have to work out those details yourself. Again, most new designers grossly underestimate just how important production planning is. In higher level projects, how something is built often affects the design details. Production planning is an integral part of the design process, not just an afterthought. Once you complete your design, you will also learn how to build the design, launch it, and how to collect and analyze flight data. How should you use this video series? This series is broken down into short individual videos organized by topic. All videos should be watched in sequence your first time through. In the future, you may want to go back and rewatch specific topics, but don't skip topics if you haven't already watched them. There are 2 different projects discussed in this series. You should watch all videos for both projects, even if you're only doing one of them. Many of these videos have accompanying summary pages that you should download and/or print for future reference. Keep all your electronic downloads on your computer or a flash drive, and keep all hard copies in a 3-ring binder. For some videos, you will need to download design forms to be used during the video. These forms are part of the design process and you will need them. Some need to be printed, others are Google Drive forms that you copy and fill out electronically. This has been the introduction to the Level 1 project. After watching this video, you should download and/or print a copy of the Level 1 project design requirements. The next 2 videos in this series will explain them, and you will use them throughout the project.